Let's start with the big picture. The image switcher can respond to two things. Enumerations, think of the set of colors a traffic light could be, red, yellow, or green, or internal states, not the entire state machine, but the individual states inside those state machines. Think of the state of the traffic light. It can be in the state of lighting red, it can be in the state of being yellow, or it can be in the state of being green. When the model switches to a new enumeration literal, or it transitions into a new state, the image on the screen updates accordingly. That's its job. But for that to happen, the image switcher needs to know what it's monitoring. Let's look at the specification of the image switcher. This is where the represents property comes into play in the specification window. This attribute tells the image switcher what element it's tracking. And this part can be a little tricky. If you want images to switch based on the states, the image switcher must represent the block that owns the state machine. Or, if you want the images to switch based on enumeration literals, the image switcher must represent the enumeration type itself. That distinction is really important. I'll illustrate both scenarios so you can see what this actually looks like. Before we jump deeper into the examples, we need to get clear on one key concept, and that's the active image. So what is an active image? Think of it like this. The image switcher is the overall user interface element, kind of like a digital billboard. But that billboard needs to know what image to display and when to display it. That's where the active image comes in. Each active image is a pairing between a condition, let's say, something in the model like a state or a value that is the active element, and the image you want it to show when that condition is true. That is, you have an image that will appear when an element in your model becomes active. You create one active image per visual state you want to show. If you have three possible conditions like red, yellow, and green, you will need three active images, one for each color. Each active image knows when this is true, display that image. In CATIA Magic, an active image is a model element of its own, with two key attributes. The image, which is the file you want to show, like the red light picture, and the active element. That's the model element that triggers that picture, like the state of being red, or the enumeration literal that is red. The image switcher listens for changes in its source, a value property or the internal state, and as that source changes, it swaps out that visible image by referencing the correct active image. Okay, now let's go back to talking about an example. We're first going to talk about switching images based on an enumeration. So, we have an enumeration named color. This enumeration has enumeration literals, red, yellow, and green. We have a block named traffic light. It has a value property named active light. That property is typed by the enumeration named color. If you want an image switcher to update based on the current value of that value property typed by the enumeration, you must set the represents attribute of the image switcher to the enumeration, not the traffic light block. Each active image inside the image switcher will then reference a specific enumeration literal. You'll define three active image elements, one for red, one for yellow, one for green. And you will upload the corresponding image for each active image. So during simulation, when active color equals green, the green light image appears. When it changes to yellow, the yellow light image replaces it. Simple concept, crucial setup. Remember, for enumerations, you need to set the represents value to the enumeration, not the block. That part is key. Okay, now let's flip it. What if your traffic light is modeled using states instead of an enumeration? Maybe it has a state machine with the states red, yellow, and green, and it cycles through them as time passes or based on events, or I have a really simple signal here named change. Here's the big difference. In this case, the image switcher needs to represent the block that owns the state machine. Why? Because the image switcher needs to understand which state is currently active, and those states are nested within the state machine owned by the traffic light block. Again, you'll create 3 active image elements. Each image corresponds to one state. The active element attribute points to the correct state, not the state machine, remember, the individual state that lives inside the state machine. And then when that state becomes active during simulation, the image will update accordingly. Okay, so let's go back to talking about the image switcher attributes. We talked about what an active image is and what the represents attribute is with examples using enumerations and states. Now let's talk about a common issue. What if the model enters a state or has a value that you have not linked to an image? That's where this attribute comes in. Show empty image for unspecified value. So say we have our traffic light, but I forgot to set an active image for the green state. Let's start the simulation. We're in the red state. If this attribute is false and the green state becomes activated, the red light image will still be displayed. It will stay at the last active image until a new active image is valid. However, if you set the value to true, and I still have not added an active image for the green state, when we start the state machine, the light will be red. And then when it changes to the green state, this time, no image will be present. So that's what the show empty image for unspecified value attribute does. If it's false, the last image will be displayed until it reaches a new valid active image. If true, it will not display an image if there is no valid active image. We've talked about how to build an image switcher, but now how do we actually use it for a user interface? You can use an image switcher on its own. You just add it to the simulation configuration directly. Or you can embed it inside a user interface frame or panel. Let's walk through the enumeration example to see how that works. Add a frame and assign the block that owns the value property typed by the enumeration to the frame. Add a panel to the frame. Now, what do we remember about nesting panels inside of frames? The child container must represent a property of the parent container. So the block owns a value property. And that value property happens to be typed by the enumeration that defines the image switcher. So we want to assign that value property to the panel. This ends up applying the nested UI config stereotype to the panel, and it will configure it to be the image switcher. This works because you have already created the image switcher that is typed by the enumeration, and CATIA recognizes that the value property is typed by the same enumeration that you use to configure the image switcher. Now, how do we control the simulation if the light color is typed by an enumeration? We have not talked about this user interface element yet, but we can use a combo box. When you assign a value property typed by an enumeration to a combo box, the combo box manifests as a drop-down menu. And during simulation, you can select the color or the enumeration literal that you want the light to be.